Today we're going to talk about arc length. I'm pretty sure for you pre-calculus kids that arc length is a review from something you learned either in geometry, or if you were in integrated math, then you probably learned it in integrated 3. But arc length is super easy. If this is your circle, you guys know that the distance from the center to the outside is a radius. It's a no-brainer. And if you were to rotate that radius and stop, say up here, then this intercepted arc here, or the distance traveled around the circle, is your arc length. There's your arc length. So again, the definition of arc length is the distance. Sorry about that. Around circle. It's really easy. The formula is S equals R theta. Think of SRO, like your SRO at your school. S is your arc length. R is your radius. And of course, theta is your angle measure. The only little catch here is that your angle measure must be in radians. You guys are pros at that. You should very easily be able to convert degrees to radians by multiplying by pi over 180. If it's already in radians, leave it alone. But if it's in degrees, you got to multiply by pi over 180 to get it into radians before you can plug it into your formula SRO. That's it. That is it. So let's try a couple of examples. If I have a circle with radius of 5, and I tell you that the arc length, S, is 17. Find theta. So use your formula, SRO. It's not really an O, it's theta, so don't get confused, but taking shortcuts here. S is 17, your radius is 5, and theta is what we're missing. So all you have to do is divide both sides by 5, and you get theta equals 17 over 5. And you're welcome to leave it in fraction form. Unless the instructions say specifically to round it to the nearest decimal, then you should leave it in the most simplified form of your fraction. Let's try another one. Okay, there's your circle. And let's say your radius is 10. And let's say they give you theta. Let's say that they give you that theta rotates, or that your radius is rotated 2 pi over 3 units. S equals R theta. Do we have our S value? No, we do not have the distance around the outside of the circle. We don't have this portion. So we don't have S. We do have a radius of 10, and we do have a theta of 2 pi over 3. Okay, well, just do the calculations. Make sure when you multiply fractions, it's top to top and bottom to bottom. So I'm going to turn that 10 into a 10 over 1, just so I'm not tempted to share the 10 with the top and the bottom. And I get 20 pi over 3. If your instructions say that you can leave it in terms of pi, then you're done. Most of the time, They don't let you leave it in terms of pi for these because we're about to use these in the next unit or the next section to apply it to real world applications. And when we're talking to somebody out loud, we don't normally say, yeah, I traveled 20 pi over 3. No, we don't do that. So if you punch this into your calculator, 20 times pi, hit enter, divide by 3, you'll get 20.9. All right, let's try one more example. Let's just say that you're given a wheel, has a radius of 27 inches. If the technician rotates that tire or that wheel 160 degrees, if he were tracking the distance that, say, a nail that was stuck in the tire traveled around the circle as he rotated it 160 degrees, then how far did that nail travel? That would be an arc length. But in real people speak, it's like how far did something on the edge of the circle travel? Great. So let's use our formula, SRO. The arc length is what we're looking for. The radius is 27 inches. And anytime you're given measurements, you should include it in the formula because we're about to, like I said, use real world examples and you're going to want those labels. And theta is 160 degrees. But we said in the beginning that theta has to be in terms of radians. So we're just going to come right out here to the side and take 160 degrees and convert it into radians by multiplying by pi over 180, which is 160 pi over 180. And if you do the math on that, it's 8 pi over 9. I'm going to leave it like that for a second. You can go ahead and convert it to a decimal there if you want to. So this is 27 inches times 8 pi over 9. Now we're going to multiply that out. You are welcome in your calculator to do the 27 times 8 divide by 9. I'm going to take a shortcut. You can check me in your calculator. Well, not a shortcut. I'm going to show you by hand. This 9 on bottom and 27 on top reduced to 3. So that becomes 3 times 8 pi, which is 24 pi inches. And again, we don't normally talk about 24 pi inches. The technician's not going to say, yeah, I rotated your tire 24 pi. No. So put that in your calculator, and what you get is 75.4 inches. That's how far around the circle that nail traveled if the tire were rotated 160 degrees. And there you go.